Yes, we are live. How is everybody? Well, welcome to Samsung Internet. We are here. We are gonna have two really great talks. We are also trying to test some new tools and how to actually do more live streaming and to interact with each other. I think like most of us, we've been using other tools to see each other faces. And the idea of today is to actually keep learning from home. We're gonna have two speakers. One is Mahid. He's one of the community leaders about um, NGConf. Also is an organizer of the PWA Conf, the one that we're gonna have soon. And also we have Natalie soon. She's a woman tech maker. She also works for Aerospike, but we're gonna talk about them soon because I would like to have a little talk about that. How are you, Dan?
I'm doing great. I'm just here to support you for today's stream, of course, and it's a little disconcerting here because I've actually got the YouTube stream running over here, and it's running at a delay, so I can see everything that we're doing live, and there's like a 10-second delay or something like that over to the YouTube. So we're experimenting with these tools, and we're trying to make give developers kind of the best information that we can, and keep giving people the what keep doing what we're trying to do here, which is get the word out about web technologies, really promote the web platform, and bring in the voices of people that we think are saying something really interesting about the web, and that's what the purpose of this kind of meetup is. So I hand it back over to you, Laura.
Well, before we start with some talks, the idea is to also bring you some of the latest news and things that we've been doing with the team. One of the things that we want to share is our post. What are we working on? We have a blog post that if you want to check is on Medium. I will share the link here. And in the latest news that we have there, I will also share my screen to show everybody. We've been talking about, as usual, PWAs. Also, we've been talking about WebXR. I think like we are trying to go back into this topic. And also we have a really good case scenario about PWA into our blog post. So before we continue, let me share my screen quickly. Again, we are trying this tool. So let's see how it looks like. And here is where everything is broken and we're not able to share just one thing.
Do you want me to share the?
Yeah, because I'm not able to see the option to just share one thing.
Do you want to add that?
Yes, let me take a look. In the meantime, we have, as you know, we have two different talks. You can leave your questions in the chat, and the idea is to try to answer those questions during the talks, the different talks that we will have. So let me try one again. So it seems that I'm not allowed to use the same different tabs. We are testing. Sorry about that. In the meantime, you can always grab one other coffee and prepare to the amazing talks. And also, we would like to say that the whole meetup is um, under code of conduct. So if somebody needs anything, or um, you would like to share something or needs any help, hopefully, as usually our meetups are great. We are here. Dan is also there, so feel free to chat with us. Again, you can find those articles in Medium and also in our blog. The latest article is about our friend Ada, our colleague Ada. She talked about virtual reality and what's going on with WebXR into the web. So if you're curious about what's happening, especially during these times that everybody is at home, what's going on with WebXR, VR, here are the latest news related with that. And besides that, if you've been interested into PWAs, you can go to into Medium, and then if you can check our Medium website. Yeah, here you will be able to see two different things. The very first thing is, as you know, we've been talking a lot about progressive web apps. So we created a new post when you can create your own PWA step by step with a demo that we built that is called Pigments. It's like a cold app, and the steps are in Glitch, so you can see how to create your first progressive web app. And then the third one is super interesting example about one PWA. I think Dan really likes this one. It's a PWA called Made Me a Cocktail. Kevin, our colleague, he's been researching about different states of progressive web apps, and we find out that there's a progressive web app that is called makemeacocktail.com. That basically what you do is to mix ingredients, right? And then yeah, it gives you which how you can create a cocktail, and that's it. So the idea is to bring these case scenarios, explain why developers choose to create a PWA platform, and then explain the process, like behind the scenes, what happened in terms of creating a PWA, why they decided to create a PWA. So if you are curious about how to, or you already have a PWA, we are looking for more of these articles, so feel free to contact us. Alrighty, so if you have any questions or something like that, you can always write us. And then we have two different speakers. So the very first one is Mahid. We are gonna talk about performance. We are trying to bring different topics, not only related about PWA or even WebXR or other things related with web. One of the most important things in terms of coding is to also check the performance of your website. So for that, we have Mahit today. Besides that, we also have other topic that is related with machine learning and architecture. So if you are thinking to bring that topic into our table, or you want to also explain something in particular that maybe is not related 100% with the web, let us know, because we are open to that. Alrighty, I think we are just waiting for Mahid. And in the meantime, if you have any other comments related with PWAs or things that you would like to see or talks or something like that, please let us know. And that's it. So let's go with Mahid. I hope that he's there. Are you ready? Yes. It's like we're testing this studio, so there are a lot of things going on behind the scenes. So let's say hi to Mahid. How are you,
Hello.
Mahid?
Hi, I'm
How
very
are
good. I'm very
you?
good. How are you?
Yes, good, good. We're super happy to have you here. Thanks for joining
How
us.
did you actually maintain your hairs? I look at your hairs right now, both of you. It looks very nice, but mine is like, what? It's Corona situation. How even it's possible?
We have to tell you the truth. We were in like the whole day preparing for this YouTube live
Okay.
thing. So it's like I told my mom, "Hey, mom, I'm gonna be on TV." So I think maybe probably Dan also.
All right.
Yeah. I was one. I rushed to get a haircut, like when they said they were going to be doing lockdown. I was, I probably that was bad practice, but it's already. It's yeah. It's not
All
great.
right. Sounds very good.
Yeah. So,
That's
Mahid, one of the things that I like to say, or they say thanks or not, is that thanks to Mahid, I discovered this tool to do broadcast.
oh yeah.
So yeah,
Oh,
we are trying to learn how to make it.
yeah.
But just in case we have like somebody that maybe can guide us or not. But yeah, so Mahid, I would like you to have some introduction of yourself before we start, so people know about you, because we know that you've been doing a lot of stuff, a lot of cool stuff related with the web, a lot of things related with the community. So yeah, first of all, where are you now, and if you can tell us a little bit about yourself.
Um, Good. First of all, my name is Majid, technically,
Oh,
but I'm also used to Maid because I'm based in Oslo, Norway, right now, and the people here also pronounce J as Y, so I'm very used to it. So it's just no problem. But
okay, imagine.
yes, I'm based in Oslo right now. I am in my new house, which we moved yesterday. Quite messy in my office, but I try to show some good views of the office. So I am a software engineer based in Oslo. Like I said, I do a lot of things related to web and, in particular, PWA. And you probably have heard my name in that regard. I am also co-organizing and organizing a few meetups and conferences, Mobile Era, NG Vikings, and Angular Oslo, Flutter Oslo, like everything related to web and like front end technically and mobile in Oslo. I'm very glad to
So
be here
if
today.
people want to know more about PWA, have a visit to Oslo or talk about Flutter, you're the person, right?
Absolutely.
Great, 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 great.
I hope so.
Okay. Yes, yes. And your apartment looks really good. I'm surprised that you're moving during this time. So I don't know how you were able to manage that.
It was very tough, but we did it.
Yeah, yeah. Okay, so I will just leave your Twitter so people can start to interact a little bit. We're also we are doing a hashtag today. Thanks for the recommendation um, to Natalie. Actually, that is Samsung Internet Meetup. So if you're following up or you want to follow the conversation, you can do that here. I'm trying to manage to be like director or how is that? I don't know how people do those videos. I'm like having a admiration of how people do broadcasting, YouTubers, and how many skills you need to know. Okay, so the stage is all yours if you're ready.
Absolutely. I can share maybe my screen, right?
Yes, exactly. You will share your screen and then it's gonna be all yours.
So, okay. All right, I just shared. Shall I continue?
Yes.
Okay, good. So again, thanks for having me today, and thank you all that are watching me. So let's get it started, and then deep dive into the parallel computing and what we can do actually on web right now. So, all right. So all of us actually have seen probably this window, and you know that, well, sometimes you go on a web and you try to do something, and then suddenly the web is like the page is frozen, or you cannot interact with the app. So, well, technically, it makes your user frustrated, right? And I can also admit that it's not only your customer; it's also the business side, or maybe the development team, because when everything is frozen and like it doesn't work smoothly, well, everyone comes to you and say, "Hey, it doesn't work. Our customer is nagging." So what we are trying to do is to look into the different options today and see how we can practically improve the performance of a website, or let's say a web application, and what are the options. So we're going to quickly, sorry, I need to, okay. We're going to quickly go through a difference between parallel computing and concurrency. We're going to see like how it works in JavaScript and in browsers. And then we will go through 4 options: web workers, WebAssembly, worklets, and service workers. So we will learn today that how you can use this, how you can leverage these technology today in the browsers and use it in your application after my talk, like right after my talk. So everything in this talk is so practical, full of example, all practical, so you can use it immediately. No theory. So I think I don't need to introduce myself again, so I can just move on. So let's move on to the parallel computing. So when we are talking about parallel computing, so maybe most of us, or maybe all of us, know that we're talking about several entities that at the same time, they're working on one task or several tasks, right? And when we are talking about concurrency, we're talking about a single entity that is working on several tasks at the same time. Okay, but what does it do in JavaScript, in browsers? So JavaScript is single-threaded, so we know that. And in browser, technically, we have one thread that is doing everything. And disclaimer is that when I'm talking about thread, I'm not talking about CPU core, but we will get to it. What does that mean? So if I break it down, that means in the browser, we have like an event queue, and then whatever happened in the browser and your web application, it goes to this queue, and it just executed. And once it's done, it just comes up to the first, and then the next one does the things, and then goes away, and goes on and goes on. So what if then in this event queue you have an event that takes a long time? That is exactly the time that the web application is frozen, right? So your user wants to do something, but they cannot. They just, like, for instance, click on some buttons, but it doesn't work because another event is in the queue and it's happening at the moment. So we're gonna actually touch this part today. How can we solve this problem? How can we improve the performance of the web application and solving this problem? We have several options. The first one, perhaps, is around for years and years, and many of us, like when I asked in the conferences and meetups, mostly 90% or 95% of the room, they know web workers. So we're going to go through the web workers. But why I'm bringing this up today? The reason is that when I'm talking about web workers, everyone knows what it is, but maybe 10% use that actually. So today I'll tell you why you need to use web worker and how can we use it way easier than what you think it is. So the web workers, for those probably who doesn't know that, the web workers are spawning another instance of JavaScript engine, and they run in a worker thread. So first of all, the most important thing is that the thread is different from main thread. That is, everything is happening. And the way that it works is working via messaging system. And that is the bottleneck of probably to my eye, to the web workers. So let's go through it. How does it work? When you actually have a message, when you have your browser event queue, you can send one of these events, like the long one that we discussed, to the worker thread via this messaging system. And then once it's done, then you can send the message back to the main thread and you see everything, right? All right. But isn't it like concurrency? Well, of course, it is looking like a concurrency things that we discussed, but nothing has stopped browsers to run this thread in a different cores. In fact, we as a web developer, we don't know. We don't know if it's happening, but if it's happening, that is a parallelism. So that is a parallel computing. So then we should consider that probably as also a parallel computation. So, but what are the use cases for these web workers? A lot of use cases. So usually those heavy computation. So if you have like some functions that they need to be executed and they take time, then you probably can send them to a worker thread. Once that's done, you get the result back. Or if you have image manipulation, encoding, decoding, or those kind of things, you can definitely use web worker. How does it work? Again, to just refresh our mind. That is the main thread. We have a worker thread, of course, and via this post messaging system, you send the message to web worker, and you will get a message back to the main thread once it's done. All right. How does it work in the code? You definitely have a worker constructor, so you can pass your worker JavaScript file. Again, that is simply a JavaScript file. So once it's done, you can send this message with post message function, and what you send, you will receive in the worker thread here on message events. And once you have that, you can do whatever you want based on what you send. For instance, this example shows you that I send an action called power2 or whatever, and then I do some computation. And then once the result is done, I'm sending back another message with this payload back to the main thread. And of course, my main thread is now ready to listen to this message that is coming and react to whatever I want to do. For instance, if I want to manipulate the DOM. Let's look at an example, actually. I'll give you an example actually in React shortly. But before that, one question, maybe if it comes to our mind, is that Isn't it easier instead of having this post messaging system, like go there, come back, and isn't it easier like to get access to this function immediately to the worker thread? Like you construct your worker and then you just call the function and then get the result back. Like a natural way of doing the things in JavaScript normally, right? And it's even better if it's promise based, right? So you can just wait for that or use .then chain. Of course, it's better. And here's what I'm actually introducing this library, comlink, a library from Surma, a developer advocate at Google. So to me, it's a very nice library that you can use for your application and leverage web workers. Let's have a look at these libraries. The usage of this library is very simple. So as you see in an example, again, you have your constructor. Once the worker is ready, you just need to use a proxy or a wrapper from the comlink library, and then you will get access to your what you exposed from worker.js. Let's have a look at the worker.js in this example. In this example, my worker.js file has a service object that has two functions. So now I'm exposing this service, right? So if I go back to the previous code, you'll see that when I wrap this worker, then I get my service, and then my service right now has access to the function which I defined, which is power2. And nicely, it's wrapped with promise, so it's promise-based. You can simply await for that. So very natural way of doing synchronous way of doing JavaScript code, right? Very simple. Let's look at an example as I promised. I have, this is an example. You can use comlink in any framework, any JavaScript application, no problem whatsoever. So what you need to do is, this example is a React application. So I want to fetch my list of users, and deliberately, I have a list of users over 3,000 in my array, and I want to sort them based on some factors, maybe based on age, for instance. Like I said, I deliberately did that. The reason is that I want to freeze at the main thread, because this computation takes time. So here is the function that I introduced. So here is a function. Now you see that I have access to my worker service, worker service, and then I have access to the sort function that I define, and it just takes my list of users. And once it's back, I will get my sorted array. Let's have a look at the JavaScript part of it, the worker part of it. So here's my service object, as I mentioned. And then I have my sort, for instance, asynchronous ascending. Here is, again, deliberately not optimized function. So I just want to sort. Here is a two loops. So, it takes time. So now I want to actually sort this user list. And then once it's done, I just return a list. Fine. That's very good. So let's have a look at this example in action. I want to play this for you. I have this application. I want to just use ascending with web worker. If you look at the example right now, I hope that in the streaming it's not lagging, because it's very important. You see that this animation right now, it's working very smoothly. But if I do this ascending or descending without web worker, then it's freezing until I get this computation done, because I had this exact same function in the main thread too. So here is the example, how I could simply offload my computation to my worker. Very simple, synchronous. You get the result back as a promise, and you're done. And the web is very smooth. I'm pretty sure right now you will have a lot of more use cases in your mind, which you probably face in daily basis. Another example, another option is WebAssembly. Let's talk about WebAssembly. When I talk about WebAssembly, the first thing it comes to our mind, usually here I ask audiences question, but now I have to also answer this question. So the first thing probably it comes to our mind is performance. Maybe it's C, C++, Rust, these things, it comes to our mind because we are kind of surrounded with these articles that they all shows these examples, and they said that WebAssembly is awesome. Of course it is, and it's performant. But we know that WebAssembly, of course, helps us that to bring the different languages to browser to run them, right? And many languages right now, actually, they have support for it. But as a JavaScript developer, as a web developer, we usually don't deal with C and C++. And, in our daily basis, we usually write JavaScript and deal with that. I'm not saying that we cannot do that. Definitely, we can go and work with any languages. It's a matter of skill and time. You can learn it. But isn't it better if we have an option that is very familiar to us, or maybe easy to use for like a web developer, a JavaScript developer? Here is when I'm talking about a new option. Assembly script. Assembly script technically is compiling a strict subset of TypeScript. So, it's like TypeScript. TypeScript is also a subset of JavaScript. So you're technically writing JavaScript. But as I mentioned here, that's the strict subset of TypeScript. So you have WebAssembly typing. So you cannot use any typing that you want. So you have those standards from WebAssembly. Usage of WebAssembly, it's going to be very exciting because you now can go and write your WebAssembly and maybe port some library that is written in assembly script or something else, and then use it in your web application right after my talk. So as simple as installing assembly script via npm, and then you just initialize the application which you want to create, or the script that you want to write with npx, for instance. And here is the code, as init, and the folder that probably you want to run that. Once you do that, you'll see these folders. You see an assembly folder, you see assembly index.txt folder, and you see a build folder, index.js, and all of those files. So the index.txt file is where you want to get it started. So where you want to actually write your TypeScript-like code. So let's have a look at an example. I have an example here. So the previous example from web worker, like Power 2, for instance, or like Fibonacci, for instance. I wrote a function here, not optimized at all. That's deliberate. And you see that here, I'm just simply, it looks like very looking like TypeScript, right? The only difference is that you have I32, integer 32, as a type. And these are the type of assembly script. So you can get a list of these typing and get familiar with that. So probably this is the most important things that you need to do when you start with assembly script. So there is something about WebAssembly is that you still need to deal with the memory allocation. And of course, it's going to be maybe a challenge for especially for web or JavaScript developers, let's say. But there are some handy tools in assembly script that makes it easier for you to work with that. I know that there are some progress in WebAssembly that probably the memory garbage collection will be automatic, like JavaScript and those kind of things. So that is coming to WebAssembly, and I know that they are working on it. So maybe in the near future, we don't even need this. So, and how can I build my WebAssembly file? And by the way, a shorthand of WebAssembly called WASM. So when I run npm run as build in my project, which I already initialized, so I get all of these WASM files, untouched and optimized, and of course source map for debugging, right? So it's great to see that I get two versions, because it's like when you ship to the production, and you need to use the optimized version, and when you ship for development, for testing, maybe untouched version for better debugging. But all right, if you have tried WebAssembly, you know that there is a little bit of work when you want to instantiate it, and when you want to fetch this WASM file, instantiate it, also get access to the expose function. There might be some work here. But what I like about WebAssembly script is that there is a handy loader from assembly script. We can technically import it, and you can, as soon as you fetch your WASM file, it does all the heavy lifting for you, and then you have access to your WASM services, which technically you exposed from your TypeScript file, right? Here is an example in React again. So I implemented, you see that how I actually instantiate my WASM file. Very simple, maybe very familiar to you. And I also wrote the exact same function for Fibonacci in JavaScript. Exact same, I just removed typing, right? So I'm going to actually test this function and the function that I wrote in the WebAssembly script. And I want to see actually which one is more performant, and if it is performant at all. So let's go and get the very high number for Fibonacci and see how does it work. Before I run that example, I'd like to mention here that when you are using some tools, it might be very performant for one use case, but not for the other. So always measure what you are doing and see and compare to what you have. So that is very important, that you need to measure. And I did this measurement for this example too. So this number for Fibonacci number, when I run it for WebAssembly, the first time, okay, I'm emphasizing, the first time I run this function, the time of execution was around this time. You see, around 5 milliseconds or something, or less than 5 milliseconds. It's like hundreds something. And then in the JavaScript version, when I compared, so the performance of the WebAssembly function was around 7 times faster. Again, for the first run. Let's actually see it here. I console logged it. So that's the number from WebAssembly and without WebAssembly. So you see that there is a difference here, and it's around 7 times. And why it's like that? Is it like WebAssembly 7 times faster? Well, it might be or may not. So the thing is that the first time when I run this function from WebAssembly, it was way faster. But the second time when I run it again, the execution time for both functions from JavaScript, the main thread, and WebAssembly were exactly the same. So the thing is that the JavaScript engine, when you run this function for the first time, it tried to optimize it, but for the second time, it's already optimized, so it runs faster. And that's here is where the benefit of WebAssembly comes. If you need a steady performance for your application for some reasons, so if you want to stay in this path, you definitely need to consider WebAssembly. The reason is that WebAssembly, if it runs performance, it will run performance. So, and it will stay performant. That is very, very important to know. So again, measure what you are doing and consider the best option for your case. So a third option when it comes to parallel computing or concurrency here, worklets. Let's talk about worklets. Worklets are, again, a light version of web workers. They are built on top of web workers. That's why I brought up web workers first, because they are very important. All of these options, WebAssembly and like worklets, they are just built on top of web workers. So a light version of web workers. So all of those features, right? And the thing is that in Worklet, you have access to the very low level of the rendering pipeline in the browser. What does that mean exactly? That means you can render graphic, or you can process audios, like from very low level pipeline in the browser. You can imagine like how performance it could be. So it's also possible to run WebAssembly and technically JavaScript. Well, it's the default one for worklets. How many types of worklets we have? I'm going to introduce you 4 types. And for now, we have these 4 types: paint, animation, layout, and audio. For this talk, I prepared just talking about paint. The reason is that it's more adopted and implemented in the browsers, and you may want to consider it even earlier, because the rest are still in process of being implemented or considering to be implemented. So let's talk about the paint, which is mostly available in many browsers. You may have also heard about this Worklet Paints API as custom paint or Houdini's paint worklets. So these are the different also names for this API. Let's have an example. Okay, so when I'm talking about like rendering a graphic, what does that mean exactly? Imagine that you want to actually create a checkboard exactly as this function that I wrote, and you want to actually render this checkboard you created. And you see how we can do that, right? So first of all, I register my paint, which is technically a class or a function in JavaScript, right? And I name it checkboards. That's very good. That's my checkboard JavaScript file, which I'm going to instantiate it as a worklet. Let's go to the file or main thread that you want to instantiate this. So here, well, a good practice for building application or progressive web application is that it is good to check for all the features that are available in the browser. And if not, you should probably give your user another option or show them different things, right? That is very important in progressive web and progressive web applications, PWA also, because at the end of the day, we want to boost user experience, right? So we don't want to lose some part of our application users due to the lack of the feature in the browser, right? So here is where I get access to my paint worklet. So very simple. I already created my JavaScript file worklet, registered my paint as you saw in the example, and I just added to this paint worklet via add module function. Here you go. When I go to my CSS file in a background image, I can say that now please render or paint this checkboard for me, which I created and I registered. That's awesome. Let's have a look at an example. It's loading. That is the example right now. So here is the background that I actually created in as a paint worklet. So you see that immediately. But okay, so you may say, okay, that is very simple example. But what could be like a very practical example? So I want to use this, but what can be the example? The example is in many applications, like this one, which recently I was also a part of developing an application that I need this, was rendering this barcode or QR code, let's say. Just pay attention to the, hopefully, again, you see it very smooth via streaming, but you pay attention to the animation, the red circle here. It works very smooth, even though I'm rendering on the fly. I'm re-rendering on the fly that QR code. So that is exactly an example for using these paint worklet or CSS Houdinis. So a great example that you can start using that maybe from tomorrow. And of course, as a PWA person, which I have a lot of things regarding PWA, I also need to talk about service worker. But you may immediately ask service worker, well, they don't have anything directly connected to the main thread, right? Well, maybe yes, but there are some options. There are some options. And I'm happy to share those options with you, how you can leverage service worker in this case. Let's move on to that. First of all, service workers are, you can use them everywhere, like in all frameworks. It's just pure JavaScript, right? You can write your JavaScript service worker via different options, and you have it ready for your application. So that is great. And I have a full talk about service worker. I linked it in the presentation, and I hopefully share this presentation to you so you can get access to all of these examples and the links. So you can have a look at this talk. It's around 1 hour. So I deep dive into the service worker. So I call it it is called brain of PWA, right? The reason is that it works as a proxy. And another good thing is that it's a type of web worker. So, and it runs in background. When I say that it works as a proxy, it means you can intercept all the requests, network requests, and you can manipulate even the request and respond, right? All right, it's a lot of possibility right now. By saying that, like I can intercept all the network requests and do whatever I want and respond, right? Very good. There are other things that service worker can do, like caching or push messaging. I'm not talking about those. I'm particularly interested about intercepting network requests in this case. So, quick example of a service worker. How does it work? Is that when you come from a web application, if you have a registered service worker, so definitely it comes to the service worker first, and then you can do what you want with this request. And of course, if you're offline, it can go to cache or get the response from cache. Or if you're online, you can decide to send it through network and then get a fresh data. So there are different strategies for caching and things. I'm not going to talk about that. But here is where I'm talking about a service worker. Before that, just to refresh our mind, to register a service worker, you can technically use Navigator service worker, and via a register function, you can register your service worker JavaScript file. As I mentioned, it's just JavaScript again. So here is an example when I say I'm very interested about service worker, because you can do a lot of things on the fly. Like the request comes, you want to send a response back, but you can manipulate that. And here is a great example of my friend Kenneth, which he has done a few times. I hope he's online and watching me right now. Okay, hi Kenneth. So he did a great job here, a great example that needs to be mentioned maybe 1,000 times. And here is an example that you can, when you listen to the fetch, when you listen to intercepting these requests, you see that at that time, when he was doing this example, there was no support, or there was a very bad support of WebP image extensions. And WebP is quite good, like low size and high quality and etc. So he wanted to support WebP for those browsers that didn't support that. So the reason it was again to use these images. At the same time, do not interrupt users viewing the images. So like those users that are using some browsers that didn't support service worker. These today, all of the green browsers definitely support the service worker. You don't need to worry about that. But of course, that is a great example. So what it does, when the request came to the service worker, he listened to this extension images, extract them, send it to the web decoder, and get back a decoding version of the image. And of course, he decoded to a BMP in this case and send it back as a response to web. So you've been using WebP, but your user technically was seeing something like a BMP image. It was a great example. So now you can, I'm pretty sure that it comes to your mind immediately how many use cases you have right now that you can do with service workers. And again, since it's running in a different thread and background, so it doesn't interrupt anything. That's great. So let's go through summary. It was a lot of things to mention. So first of all, what we learned today was do not scare using web workers. And web workers are awesome. That's great. Many of the other options are a light version or built on top of web workers. So use Comlink if you are scared of using post messaging and if you find it very annoying. That makes it very easy to work with service worker. Do not overuse it though. You don't need to send anything to web workers. You just need to think what you should, what it makes sense, and what is blocking in the main thread or takes a time or it's heavy computation. WebAssembly. So it's another option, another possibility for us to make our application more performant. If you don't know how to use other libraries or how to compile to a WASM file, you can definitely use assembly script, start using your functions and run it on your browser and your application today. Service workers are awesome because they are intercepting a request, and you can manipulate this response and request and send it back to the main thread. And worklets, they are great because you get access to the very low-level pipeline rendering engine of the browsers, JavaScript engines, so you can render very high performance out of the box. At the end of the day, to have a better web or to have a progressive web application, our goal is to boost user experience, right? Use different options in the browser which are available, especially for those users that they have these possibilities in their browser that they are using, and give them a better user experience. And with that said, thank you very much for listening to me. This is a short link of these examples, especially all of the codes are written in React in main thread, so you can use them. And I'm very glad to talk today. If you have any question, feel free to send it to me right now or after the talk, or maybe tweet me. I'll definitely answer. So here I am.
Oh, Laura, you're
Laura, you're muted, I guess.
Yeah,
I'm on mute. Yes, yes, as usual. It happens to me in our meetups, in our meetings, and also here, right? I have to have a certain kind of
how
continuity
difficult is
about
that?
that. Yes. Well, first of all, thanks a lot, Majid, for that talk. That was amazing.
You're
And
welcome.
actually, we have I have also some questions for you related with performance. I think that's something that especially developers have to take care about because it's there's a proof that if users find out that there's your website is slow, they just
Yeah,
leave and they're not gonna
absolutely.
use it. So we learned about new different tools to use today, how we can improve that. But which are your tools, the ones that you choose to actually um, check what's going on, right? To
Mhm.
have some measures or and then make those decisions because we saw different types and probably
Yeah.
maybe later combine that. But which are your tools?
Yes, a very good question, I guess. I'm using several things, and I can mention them. Maybe some of them make sense to some people and some may not. First of all, the most important thing is I always think that I'm customer. I test my application like what they do, right? And I try to do that. Like if I see somewhere or something is lagging or the animation doesn't work smoothly, then I try to improve it. So I mean, the first and maybe the most important thing is yourself. So at the end of the day, we are also a customer of other web application. We are developing a web application for some users, but at the same time, we are using millions of web pages, right? So if we respect our customer and we put our customer, we think we are our customer, then I guess we definitely can find all of those issues. Not maybe all of them, but the most apparent one. The second tools that I use, most of these browsers have developer tools that you can definitely run different tests on that. So I use that too for different use cases. Like for instance, Light. What is Light? Um, what is the plugin name from Chrome? Light Speed,
Oh,
right?
the Lighthouse.
Lighthouse. Yes.
Yeah, yeah.
Thanks. The Lighthouse I use. So what we do with Lighthouse is we use a headless version of it. That means what you can do when you run your application, we send it to our CDCI, and then it runs, and then we have some criteria. So, and if we see some decreasing of numbers, then we send a notification to our team. So the good thing about Lighthouse is that you can use it in browser, and also you can use it as a headless version. So, or maybe Chrome headless, you can integrate with your CDCI. So it makes it very easy to test. And we also have a bunch of open source project, which definitely you can go and search. There are some tools, open source, that you can use to measure your script. But we use some of them for different projects, of course. But one thing that I can say is that once you wrote something, if you want to measure it, so you can measure it also yourself, you can just execute those script or functions yourself, as I did in this example here, right? So you can definitely run it yourself in any environment that you wish. So makes it very easy. I mean, I'm always thinking that we should make everything simple. So maybe there are lots of very complicated tools, of course, but depends on the use case and depends on what we are developing. So the different tools can do different things, of course.
Yeah, so we have other question uh, from Adrian. He said, what would you say is a breakpoint to start using web workers? What makes you decide to start using parallelism in a web app?
Yeah, well, That's exactly back to the previous question. I want to boost my user experience, right? And not everything is possible in main thread in only one thread. So I just want to leverage this. So if my user is not happy when the web application is running and they click on something and it doesn't work, so I'm not happy too. So that's the reason I'm thinking that we should use all of these possibilities. Of course, I understand that, as a web developer, things is changing quite rapidly, and we need to come up with like learn a lot of things. But again, as I mentioned in the talk, there are a lot of tools also introduced by different great developers, like both of you actually, Laura and Dan. So you can use these tools definitely and leverage those possibilities in different browsers. And again, when we have these options, why not using that? Just use it.
Yeah, I agree with you. And also, there is something that we should keep in mind is to actually put yourself in the position of the user, right?
Absolutely.
Because one other thing that at the end, we are building something for the user. So even though we can really like one platform or not, at the end, it's the user, the one that we want to reach out. So we have to check what's happening behind the scene.
Absolutely.
And also other thing that uh, I was thinking about is, did you have any challenges trying to test your performance in different platforms? Let's say, is something that you keep in mind when you are testing in your mobile and then you go back to your desktop, especially because of connection and things like that.
Yes, 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 yes. Very, very good point. Very good point. So I forgot to mention that when you asked about the tools, when we develop, I'm talking about myself right now. When I develop something, I always develop in mobile view, and I mean the mobile is my first choice, and 3G network is my first choice of network. So as low as possible, and I always decrease the number of CPUs and the performance of the CPUs. Like I threshold them like 2-3 times lower, so that when you do this, then you see how laggy probably your web application is right now, maybe. And even sometimes it takes time to load. So when we are talking about performance, it's the performance when the application maybe is running. Another thing is that the time of loading this application, that is also very important. But that's a different thing. So you need to think of it like initial load. Let's say if on 3G is 3-5 seconds and I'm not seeing anything, okay, bye-bye, goodbye. No one is waiting for us. The world is not waiting for us. We need to improve our application, definitely. So these are the things we need to take into consideration when it comes to also, I guess, maybe it's not exactly performance, but definitely it's a loading performance time, or let's say performance time problem, let's say. So we need to fix this as well. So breaking down our application to the different files or different chunk of JavaScript file, load them on demand or cache them. Leverage service worker, definitely. As I mentioned, one of the possibilities in service worker is to have different strategies for caching. So the first load, all right, 3, 5, 6 seconds, but the second load under 1 second or under maybe 500 milliseconds. That is awesome. It looks like a native application, right? This is the exact feeling we want to give to our user. So they have to feel they're using a native application. So if we use these features from the browser, they can see that. And they can see how powerful web is today. And we should
Exactly.
leverage and use that.
Exactly. We can give the power to our app to also reach more users, to have this kind of engagement. That's at the end, that's what we want.
Exactly.
Alrighty, if anybody else have a question or something like that, they can write it there. And I have a one final question for you. Talking about service workers, we've been also working a lot with WUA in our browser and things like that. And there's something that is called offline first.
Yeah,
It's a way to basically think that the user should load your app as it was offline first. Um,
absolutely.
Similar like mobile first, that you have to test your
Yes.
app into a mobile device first.
Mhm.
So what do you think about that? Is a certain case scenario when we actually have to think about offline first? It applies to most of the things. And what do you think in terms of trends?
Mm.
Because we know that currently we're gonna have 5G soon. Anyway, I still have problems with my 4G, or if I go
Same.
somewhere else, I don't feel like a really good connection. So I think like even though we are trying to improve our network,
Mhm.
we still have to think in these case scenarios. So what do you think about offline first?
Um, well, you're asking a PWA guy, so I definitely say you have to go for it. So I don't make any exception, but I believe it actually. When I say mobile first, offline first, that's definitely my choice, and I believe in it. And I've seen many use cases that I just implement these approaches, and they've seen a huge boost in their different criteria, like maybe sales, or most importantly, for visiting, right? So revisiting or visiting the website. So I guess again, one thing that many developers are maybe afraid of is handling the cache for this offline first. And caching, we know that is a difficult subject in computer engineering. So that's probably one thing that when we are talking about offline first, and well, of course, that means caching is involved, definitely. So it probably scares some developers. No, 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 I don't want to deal with caching. But again, all right, I know that this is caching. I know that this is some thing that you need to deal with. But there are tools to make your life easier, right? Make it very quick right now. I think Natalie is ready. So uh, the tools like, for instance, Workbox, let's say, right? If you want to deal with caching, write all of your service worker yourself and make a very big service worker, which is going to be out of like control at some point, then it's going to be difficult. But if you're using some tools developed by different vendors and different teams, like for as an example, Workbox, then it's easier to start using these approaches, right? So then tools helps definitely. So we need to start using them. Again, offline first, mobile first, definitely my approach. Go for it. All use cases.
Amazing. Yeah, and there are a lot of different tools that you can try it out, and it can be hard, but actually there are a lot of things in the community tools that actually make our lives easier. Okay, so thanks a lot, Majid. I think
Thank you.
we are done today, and actually we're gonna share these slides in Twitter probably. So yeah, we're going back to the next talk. So thank you.
Thank you very much. Have a good evening.
Bye.
Bye.
Alrighty, so let me quickly go to Natalie. Hi, Natalie. Welcome.
Hello. Thank you for
How are
having me.
you?
Good. How are you?
Good. We are super happy to have you here. We have a completely different topic now, but I'm so excited because I think it's a way to bring an interesting topic to many developers that sometimes we are a little bit afraid every time that we hear about AI, machine learning, or things like that. But first of all, I would like to know, where are you now and everything about you. Could you please
I am
introduce
in
yourself?
Marseille.
Okay, that's a good point. I'm in the kitchen also, so it's like a bar.
No, I normally work from home, so actually I came prepared for the situation. This is my regular office. So I recently got myself even a improvised standing desk. Let's say it's 2 shelves from IKEA,
All
but it
right,
works
yeah,
really well. Yeah.
yeah. It's like a step by step. We are adding more things into our home office. It's
Yeah.
like everybody is trying to do their own workstation, even though that
Yeah.
I didn't even have like a good microphone before, but right now it's like I'm thinking to buy a good microphone. Where are you
Yeah.
based, Natalie?
I'm based in Berlin.
Great,
And
Germany.
yeah, in Germany. And I might have a special guest. So I have a cat. And as you know, cats love shelves. So if you see Southern Retail here, just say hi to Java.
Of course, it's a special guest. Why not?
Java because she's her official color in her passport. So in Germany, cats have passports. And
Oh wow!
its color is a chocolate brown. So she's named after the coffee beans.
All right, I didn't know that cat has passport. That's like a VIP thing. And could you please tell us about your role? Where are you working right now? Which are your day-by-day work?
I work for a NoSQL database called Aerospike, and I actually enjoyed the previous talk because it was utilizing so much of parallelism, and that's probably one of my favorite things. So back to university days, my major, so I studied computer engineering, and my major was actually parallel programming. So I studied languages like CUDA, which is NVIDIA's language. That's a topic I've been passionate about since forever. And my favorite language is also Go because it has such a good parallelism and concurrency and so much focus on the difference between the two. And I enjoyed this field very much. That's also why I chose to go to join to the Aerospike last year. That's a database that I used to work with as a developer. And when I decided I'm looking for my next adventure, I said, let's go work for this really cool tool that I like. So parallelism, everything, yes, absolutely. It's going to be a big focus of my talk as well.
Great, great. And also you're a Women to Maker ambassador, right? You work along with
Yes,
the community.
Maker is a program by Google developer groups. So the focus is to bring more women to the industry. But so I started the Berlin chapter in 2015. That's 1 year after the global program started. And we said from the very first day, we want to make the Berlin tech scene more diverse. So we're always open for people of all genders and of all backgrounds. And in the beginning, that was not completely acceptable, but now it's completely cool. But we're still happy to always have people from all backgrounds. And by now, many cities have many chapters of women tech makers. So if anybody's listening and looking for a cool meetup to join, I can recommend.
Yeah, I think that I went to one of your meetups, but just to listen, probably a long time ago when I just arrived to Europe, and one of my first cities was Berlin. So probably we even already met. So that's super cool. Yeah,
Was
maybe.
Berlin your first stop in Europe?
But I was women tech makers meetups like 2 years ago. But I'm pretty sure that you were already there. Maybe I didn't meet you in person, but whatever. It's okay. We are here all together in the cyberspace.
Yes. That's really
Alrighty.
cool.
So if you want to contact Natalie, it's the Twitter there, so you can follow her, and then the stage is all yours. So whenever you want, share your slides, and good luck.
Thank you. All right. So unless you're saying something, I'm assuming you can see my slides. And in the slides, you can see my Twitter as well as the Twitter of this meetup, as well as the hashtag for this meetup. And I definitely want to start by encouraging and saying anything cool you learn or see, please share on social media and please tag and tweet. It's even easier these days. And this is the CAPTCHA challenge. And 2 years ago, I helped a friend to test a project that he was doing. So it's kind of like a mini CTF or capture the flag or a hacking competition for conferences to do between talks. And the way I was helping was to test the different stages and to see if it's realistic to do within the time frame that is dedicated for this. And this specific one was to break into this CAPTCHA. And the way to do this is, of course, brute force. So try all the combinations from 0000 to 9999. It sounds pretty simple, but there's a CAPTCHA text there, and then every time you need to have, if you don't want to type this and you want to brute force, you have to code this in some way. And so I used the Go programming language actually to do this, and it's indeed possible to do in a few hours. These were the steps that I did. So for the first step, you inspect the model. The model is the machine learning model, which was provided, and this was kind of the win from the previous stage of that challenge. By inspecting the model, you get all kinds of information, like what's the input, what's the output, format, and so on. Next step is load it into the code, and then try to log with the pin. So 0000 is the first attempt for the pin. And when you do this, you first of all open a cookie jar when you connect to the web. You get the CAPTCHA image, you do the prediction using the ML, and then with the combination of the current pin, you try to log in. And if it happens that the prediction, sorry. If it happens to be that the CAPTCHA is wrong, you fall back into step 2 and you have the open connection cookie jar, so you're still good. If you want to read about this or see the code, you can go to the blog post of the Gophers Academy Advance series. So this is something fun that the Go community has every December. Every day there's a blog post about some Go-related topic. And if you want to see the code base, this is the link on GitHub. I'm sure this will be either recorded or uploaded, or you take a screenshot. And the worst case, you can ask on Twitter. I will share the link again. But I am not a data scientist. I am not a machine learning specialist. I studied computer engineering, and I designed chips in Intel in my first job. I spent the last 5 years working in Go, and now I switched to do cool things in databases, still focused on parallelism. Still, I managed to do this really cool thing with machine learning, and all I had is my knowledge in Go. So in the past, I gave talks about machine learning and about Go and how you can use Go for things like system programming. And in this talk, I'm kind of excited to connect all the dots together. I will be describing the beginning of my journey in building an end-to-end machine learning from scratch based on the existing knowledge that I have, nothing else. Any machine learning engineers in the crowd, or web developers, or platform engineers, or DevOps, I hope there's a good mix in the crowd so that kind of between everybody together, the dots will be connected, because definitely a mix of skills could be helpful for this talk. And I hope that in the next 45 minutes, there will be those aha moments where something sounds familiar, and a lot of moments of like, wait, what? And I hope that by the end of the talk, you will leave the room with a little bit of understanding of the end-to-end, so really the full part of a machine learning production system, and the passion that's coming with, oh my God, there's so much that I don't know and I need to know. And the last two things, I will be asking questions. I guess it's hard to make this interactive, but if you sit at home from the other side of the screen, just say yes, no, and I'll imagine you're participating with this. And if you see anything cool, please share. I want to say that this is what you see on the screen is me as a gopher. The gopher is the mascot of the Go programming language, and there's a really cool tool that's called Gopherize Me, which you can go and build your own gopher. So what is a machine learning?
I think we missed Natalie for a second. Yeah, I think she's back now.
All right.
Yeah,
Should I jump back?
Commercials, go back. That's it. You can go ahead.
Repeat the slide.
Yeah, if you can go to the previous slide, better. I think so.
Previous slide was what is machine learning then?
Exactly. That's where we stay. Okay, all yours.
I hope everybody has the time to Google. Basically, machine learning is the creation of algorithms which modify itself without human intervention when you produce the desired output by feeding itself through the structured data. It's a subset of AI. What is AI? Many things. This is a great picture that I got from Twitter. The handle is the Alex Freeman, and it kind of covers how AI is just a tiny bit of it is machine learning, and there's so many other things like NLP, and then intelligent robots, and computer vision, and supervised learning, and unsupervised learning, and text and speech, and planning, and scheduling, and whatnot. Wikipedia says that artificial intelligence by computer science is what machines demonstrate, unlike the natural intelligence, which is what us humans demonstrate. And at the birth of this field, back in the 1950s, AI was defined as any machine that is capable of performing a task that would typically require human intelligence, such as learning and problem solving. Okay, so we know kind of what's machine learning, what's AI, what's the difference between them. How do ML? Those are generally the steps. First of all, define what's your problem. How do you define success? How do you measure it? For example, is success responding in under 100 milliseconds, or is it responding with accuracy over 99.9%? Then gather the data. If it recognizes numbers, don't include in your data set letters. If it recognizes English, don't include Vietnamese characters. Of course, there's also a trade-off. If you want to learn the handwriting of one person, you're probably going to be super specific in the data set, and then your precision is going to be pretty good, but it's not really a wide use case. If you want to, on the other hand, if you want to have the data of many people, so have lots of handwritings, it's probably going to be lower precision, or you'll need a lot of data. Then you prepare the data. You clean it, so for example, you remove 30 pictures, you pre-process it by standardizing the pixel ender at 0, kind of like in prediction, and you randomize. So if you do prediction of numbers, you don't want to always feed it as 0, 1, 2, 3, 4, 5 in the same order, because then the machine will always guess if this was 1, the next one must be 2. And you split your data set. You take 75% to be your training set, and 25% to be the testing that you use in the end. And then you choose a model. That's based on the learning task. Is it classification? Is it regression? Is it something else? And then you know the number of inputs, and then it can be multiple, it can be singular, and then the possible number of categories is possible number of outcome options. So if it's hot dog or not hot dog, the category's number is 2. If it's digits, it's 10. If it's faces, it's a few billions. And then you train the model. You assign random values, you predict using your training data, you repeat by adjusting the weights, so you have this equation that has variables, and you start with something, and you make iterations, and whenever you add a new category, so another optional prediction, it's called retraining. Once you're done, using the rest of the data, so the 25%, and you evaluate the model using the metrics that you defined in the beginning. For example, speed, for example, accuracy. Then you do the fine-tuning, which is touching the hyperparameters. It's different from step 5 by usually being more specific and sometimes manual. And if it doesn't work, you go back to a few steps. So you can land it step 4, where you need to choose a different model or change the input. You can land at stage 5, where you need to just retrain the model. And there's all kinds of tools that do it for you, like AutoML. Once you're done, you can go ahead and predict. TensorFlow. It's one of the cool machine learnings that does it. Let's give it a bit of a closer look. So TensorFlow is an open source software, even end-to-end platform for machine learning intelligence used mainly for machine learning applications like neural networks. It's also really good for solving partial differential equations if the pattern of starting a guess and making adjustments as you take steps sounded familiar. This is the image of a physical tensor from physics. This is more complex than the mathematical one we're using here, but it gives you a good understanding of the concept. And if it sends you back to uni days, take a moment to smile and evaluate your life until now. So a tensor is a generalization of vectors and of metrics, can be of multiple dimensions, and you characterize that with 2 properties, the data type, so integer, string, something more sophisticated, and the shape, which is the number of dimensions and the number of values per dimension. And then our tensor flows. This part comes to describe that the graph or the model is a set of nodes which represent operations, and the data flows through those nodes undergoing mathematical manipulation. And at any point you can stop, evaluate, and look at the value of your tensor or of your data at any node of the graph. This is the meaning of the name TensorFlow. What I like about TensorFlow is that it's community-driven, and it's becoming really friendly for developers who don't have machine learning backgrounds. Some of the tools that do this are AutoML, where it automates a machine learning model design for you. Basically, you drag and drop pictures and tags, and it does everything for you. And there's the TensorFlow Hub, which is a repo for models. Basically, you're a PhD student who came up with a really new cool model, and if you want to share it with the world, what you do is you just upload it there and it becomes accessible for everybody. It's all open source, and contributions are always welcome. Many languages are supported. AutoML is a tool we covered quickly. Land you back right after this step. The TensorFlow Hub lands you pretty much in this step. Black book solutions that are built on top of TensorFlow, plenty out there, lots of cool stuff. The topic of our talk is the infrastructure, right? This is a really great article from 2015, and it's talking about all the potential issues behind quickly hacked machine learning systems. 5 years later, it's still pretty overlooked and very much relevant. I very much recommend to take a picture and to Google it later. Accessible for everyone. It's open, no need to purchase or any special connection to university or whatsoever. Take the time and read this. A production machine learning system involves a significant number of components. The algorithm is just one part of it. In fact, it's about 5% or less of the overall code of a production system, looking at it end-to-end. A production system devotes considerable resources to the input data, collecting, verifying, extracting features, and to add to that, a serving infrastructure, so presenting the solution, must be in place to put the machine learning prediction in practice in the real world. We will now dive into the architecture components, and it's going to be a lot. Take a deep breath. Also good for the brain. Now, I want to say that as an engineer, I love giving practical hands-on advices in all of my talks. This means I'm going to be specific. I'm going to be specific about some tools that I'm mentioning. I'm doing my best to mention open source tools because it's great. This is by no means a comprehensive list, and there's many, many solutions out there and many other optional architectures out there. Let's start with a pretty common one, Hadoop. Probably some people here have heard this name, and if you're wondering what does the name stand for, it's High Availability Distributed Object-Oriented Platform. This is an Apache project, so this is the cool and the right logo to use with it. Apache Hadoop is a collection of open source software utilities that facilitate the network of many computers to solve problems involving massive amounts of data and computation. This is a software framework for distributed storage and processing of big data, and it's using the MapReduce programming model. This means this is a set of open source programs and procedures, and anyone can use this as a backbone for their big data systems. And it's made of 4 modules. Each one carries out a particular task, which is essential for this big data analytics. The first one is a distributed file system, which allows data to be stored in an easily accessible format and across different storage devices that are linked. Can be a very large number of those. Next is the MapReduce, which provides the basic tools for poking around in the data. It's named after the 2 basic operations the module carries out, map and reduce. Map is reading the data from the database and putting it in a format that is suitable for analysis, and reduce is performing the mathematical operation. For example, how many people under 30 are in the customer's database. Next one is Hadoop Common, which provides the tools you need for the operating system to read data that is stored in the Hadoop file system. And the last one is Yarn, which is managing resources of the system, storing the data and running the analysis. And it might sound familiar to you because some recent modern tools have been competing with it. And there are many other procedures, libraries, and features that are considered to be part of Hadoop and joined over the last few years. The flexible nature of Hadoop systems means that companies can use it freely. We said that. And it's widely used as even in about half of the Fortune 500 companies. This slide is probably the trickiest one in the entire presentation. I'm putting apples and pears together. To add to that, I'm going to blend in apples. If you haven't heard of Papples, aka Crunchy Gold Apple Pears, aka Nashi, these are the crossings of an apple with a pear. And technically, they're more of an Asian pear. Okay, so we have a disclaimer that we're going to be comparing some hard to compare things. Back to the slide. You can say that Hadoop is one of the platforms you can build a data lake with. If you're not familiar with the term, a data lake is a centralized repository that allows you to store all the structured and unstructured data at any scale. The data comes in all sizes and shapes, and you need different tools to make the platforms. Okay, so this is the big slide, and those are all types of tools you can build data lake platform with. Google BigQuery, Apache Hadoop, Apache Spark, Azure Data Lake, and many, many others as well. Those specific 4 all have Go clients. It's worth mentioning that as a big fan of the Go programming language, I'll be presenting how to do this tools, mostly focusing on Go. Next component is database. You can train models with data that you have in a folder on your machine when you learn to machine learning. But when you do this in production, you have lots of data. You need to share it. You need to have efficient access to it and organize one. That's what you use a database for. There's many options between SQL and NoSQL. Those presented for are all NoSQL databases, all have a Go client as well. Next one. Function as a service, aka serverless, one of the coolest buzzwords of last year. And this means serving models to consumers. So you have your model ready and you want to let people approach it with data and get an answer, this is what this does. The model is deployed to a serverless service, which is being queried, and it's working both for online and offline servings, which we'll talk about. Then comes data governance. You want to make your data openly available. It can be internally across different departments. It can be externally because you want to contribute a data pool of open source data that people can use to learn or use for their machine learning models. So for that, you want to filter and mask the data. You want to make sensitive data accessible in a compliant manner. For example, GDPR, for example, data control policies, like each user can see what type of data. And there's an interesting open question here. Let's say you train data with some specific, you train the model with a specific set of data, and then you were required to pull out this data from your system, be it for GDPR reasons, be it for a client that moved, be it for some other reason. Is the model that is using this data, that's trained based on this data, is it still keeping it? Can you still say that you're meeting the requirements if you pulled out this data? Think about it. Next is monitoring. You can do this for model performance. Is it wrong, right predictions, how many of each? You can monitor your system performance, how many requests, what's the processing time, etc. You can look at the resource consumption, and you can monitor your app. For example, what is the life of a transaction through the app, how many connections time out, and so on. And putting this all together creates what I see as a bare bones infrastructure. And I want to stress that this is very much my personal opinion. And I'm sure that if you Google what's the minimal thing you need for machine learning, you're going to get more than one right answer, and that's fine. That also many times depends on the use cases. Okay, so we have data, and we know that it comes in different types and shapes and formats, and it includes a lot of noise and a lot of bias. And it's important to do versioning of your data, same as you do versioning for the code, for reasons like we said about what happens if you need to pull data from the system. You probably want to pull it out also of your model. Deployed machine learning models are part code and part data. If you don't do versioning to that, means you don't do versioning to your model. Okay, so we need to make sure that we store in the system only what we're allowed to, like don't store credit card info if you're not PCI compliant. So step one, take the data, do some data governance and filter it. We've cleaned up the data, and now we can build our data lake where all the unstructured, unhierarchical, and unorganized data lives. You can also store it in a database or in an object store, like where you would store binary data like image, sound files, and so on. Then you want to make sure you control which user in your system has access to what data and make the data sets available for the different teams, like we said. So you do a second step of data governance. Then comes the training. Most common tools for that are TensorFlow and PyTorch, but there's many other tools as well. And it's important for me to stress that people have entire careers on this one square. Please be mindful of the simplification we're doing to be able to focus on infrastructure. Let's zoom in a little bit on the training. This is landing us to this stage of how to ML. And broadly speaking, there's two ways to train a model, a static way or a dynamic way. A static model is trained offline, which means you train it once with the data that you have, and this is your model. A dynamic one feeds on the data and keeps being updated as the data flows through. There's pros and cons for both models, of course. And the nice thing about a static model is that you make all possible predictions in one batch, you run it to the table, and then this basically behaves as a cache or as a lookup table. So it's easy to build, it's easy to test. The cons is that it can only predict the things we already know. So if you want to feed it with new data, you have to take it down, retrain, and put it back up. And the update latency can be really big. Dynamic model, we said, feeds on data that flows in nonstop. And the big plus of it is that it's adapting to changing data, so it's more likely to make better predictions. Let's take the example of a flower shop. You know that during the week you're selling this amount of flowers. As the weekend approaches, you're selling slightly more flowers. And then comes February 12th, and suddenly more people buy flowers. February 13th, even more people buy flowers. February 14th, if by now your model didn't tell you buy double the amount of flowers, you're going to sell out on Valentine's Day really early and miss out lots of money. The cons of a dynamic model is, of course, that it can be compute intensive, latency sensitive, which means you're probably going to have to put some limit on your complexity, and you'll need to focus more on monitoring. Okay, so we have the model trained. What do we do next? Model is ready. We want to deploy. We want to serve it. So we say we do this as a function as a service. And this is coming with the entire CI/CD pipeline of testing, integration, and so on, and the whole web flow. And then you have an output, which is called the inference of the model. Let's focus on that. So this is landing us in step 8, which is the predict. And this can also be in two ways, online and offline. Offline means you take all the predictions in one batch and do this lookup. And online means that you predict on demand using a server. The big benefit of an online prediction is that it can make on new information, predictions on new information as it comes in, which, for example, bringing back to the example of Valentine's Day in a flower shop, great. But it is compute intensive, and all the cons we saw, this is you need to put more resources and you need to monitor them better. Offline predictions, you don't worry about the cost of that, and you are likely to use batch quota, and you can do a post verification, so to ensure that for whatever input you try, you always going to have a reasonable output. But the big minus, of course, is that it can only predict things you know. Okay, so we have the inference and we understand a little bit better. Are we done? No, monitoring. Really important thing. We want to know the health of our system. We want to know the performance of our system. Now we're done. This is what I see as the bare bones architecture of a machine learning production system. If you want a slightly more detailed snapshot of the ecosystem, here's another piece of information about this. This is courtesy of Matt Turk, who has such a snapshot of the ecosystem for every year. And as you can imagine, every year the categories grow and the companies inside each category grow. Zooming in a little bit on the different parts, there is so much that we didn't mention, like AI ops and data integration and data transformation and cloud data warehouse, data generation and labeling, and cross-infrastructure solutions and search visualization, security streaming orchestration, and even this list is not comprehensive. So to iterate that point, there are many things you can do in machine learning, and everything makes sense based on your use case. Let's talk about off-the-shelf solution. TensorFlow extended pipeline is a sequence of components that implement a machine learning pipeline. And quickly going over the different parts of this pipeline, example gen ingests and optionally splits the input data set. Statistics gen analyzes and calculates the statistics for the data set. The schema gen examines and creates a data schema. And the example validator looks for anomalies or missing values in the data set. The transform performs feature engineering on the data set, and the trainer trains the model. In the validation part, There's the evaluator that does deep analysis on the results. There's the model validator that helps you validate the exported models, make sure that they're good enough to be pushed to production. And the pusher pushes and deploys it on a serving infrastructure. Okay, now let's talk about a concrete example. This is this pretty huge company whose machine learning architecture I want to introduce. I cannot mention their name today, and I cannot mention their product because it will be a clear giveaway. So instead, I converted the example to spam emails. This is not something they do. Let's say I'm sending an email. Once I click send, some of the input about me is being sent to the system. It can be sender email, receiver email, title, content, header, footer, more information. This is the entry point to the system. This is sent as a web request. You can run this with the model as is, or you can add a lot more data points, like, has someone reported this user as spam? Are there suspicious keywords in this email? But trying to generate this extra data is a pretty slow process. And if you want to be really fast, you're not going to be doing it like that. Especially if you want to have a lot of data points to make a pretty good prediction. What they do then is they run the few input data points through Aerospike, a NoSQL database that pulls out for each of the inputs the relevant information. For example, is this sender on the block list of anyone? Is this a new user? How many emails a day do they usually send? And so on. Information that they're pulling for the content is, are there some words in the content that are correlated with emails often reported as spam? Are there any too salesy words? And this creates the input feature vector. And in machine learning, an input feature vector is an individual, a feature is an individual measurable property or a characteristic. A set of numeric features can be conveniently described by a feature vector, and in spam detection algorithms, it's, for example, presence or absence of certain headers. Is the email structure more okay or more fishy? What is the language like? The frequency of specific terms, grammatical correctness, and so on. And so this is an example of how the email that I sent is being represented in the system after being pulled off all the extra data for the extrapolation that was done of it. And then from Aerospike, they get the input vector to the current email that we're expecting and feed it to AWS Lambda. And then this is storing an in-house machine learning model that they have built with their in-house machine learning team. They built it using Python. The output is the percent of the chance of the email being spam or not spam. Based on the percent and all the dynamic threshold, this gets the category, should it be marked spam or not. Take a second to take this all in. That's a lot of information, I know. This is a pretty cool architecture. Of course, there's also monitoring on top of that. And it kind of reminds of the part of the backbones one. Taking a deep step. And we're approaching the end, so let's do a short recap of what we saw. We discussed what's AI, what's machine learning, and how to machine learn. This image or this representation is a good answer to what is AI. We then discussed shortly about TensorFlow, how this is basically an abstraction of information flowing through a graph or a model, which is a set of nodes or mathematical operations, and it's undergoing manipulation, mathematical manipulation. And this is this entire process of machine learning. We talked about training and inference type, online and offline. We talked one example of what is a bare bones architecture components. So we saw this. We saw also that there's this, which is a slightly more comprehensive snapshot of the ecosystem currently, and this will be way bigger in the years to come. And we looked at a concrete architecture of a production system using machine learning and Go. And this is how it looked. The email getting enriched, serving to a model, and based on the percentage of the chance of this being spam, it's getting the category. We saw that machine learning is about 5% or less of the overall code of a production system, end-to-end one. We saw that the input data is a big and tricky part of a machine learning system. And we saw what's an example of a bare bones flow. Process the data, store the data, train the model, serve the predictions, and monitor. And if there's 3 takeaways that I would like you to take today from this talk, it's this. If you're taking a selfie now with a picture with this slide of this is what you learned, next slide, you're going to get the handles that you can use on Twitter to tag this as, hey, this is something really cool I learned. And you'll also be trying machine learning infrastructure as your home project. These are the tags. And if you're interested in following the journey as I'm working on my own end-to-end open source example of a machine learning, please follow me. Thank you very much.
Oh, Laura, you're muted again. Laura!
This stuff of trying to pretend that I'm a YouTuber, it's hard. Like,
one day I will be watching the slides, we'll be watching the talk, and then we'll know, okay, now is the time to unmute.
Yeah. Yeah, thanks a lot, Natalie, for that. That was really, really useful, especially for me, because I'm interested in learning about machine learning, but also more, it's not my background, as you said. So it's a way to bring other developers, hey, you don't have to be a data scientist. You can also create cool stuff using machine learning. And something that I want to add is that in your case, we're using TensorFlow. So there is a way to bring TensorFlow to the web also, especially because we have some web developers around that is called TensorFlow JS. I don't know if you had the chance to work around TensorFlow JS or something like that, Natalie.
TensorFlow is awesome. It's good for work with JS. It has also embedded that you can use on tiny IoT things or on the phone. It's by now it's so comprehensive and covers so many use cases. I'm definitely a fan.
Exactly.
Yeah. Peter, who was a member of the team up until last year, did a blog post about a prototype that he built for computer vision using TensorFlow JS called Llama Vision, basically that uses TensorFlow to determine whatever the camera is looking at is in fact a llama, which I love. I love this use case. It's great. And it can tell the difference between llamas and other, similar kind of animals. I posted the URL into the chat as well. The other thing that and by the way, I really enjoyed the talk as well. Thank you, Natalie. The other thing that I dug up, because obviously we just heard from Majid. One of the things we heard from Majid was about WebAssembly, and I just dug up a project called Google Media Pipe, which looks like it's trying to take TensorFlow and or some kind of machine learning framework and bring it and implement it in WebAssembly as well. That makes a lot of sense to me. I don't know anything about it. I just know that I saw the website. But are you aware of other kind of projects like that are kind of like bringing machine learning into the web browser or into web applications?
That's the least of the experience I have with TensorFlow, unfortunately. If you had asked me about what interesting things can you do about that with mobile, I would be able to tell a little more.
Well, what interesting things can you do with mobile?
So good that you asked. So TensorFlow, you can have, it's called TensorFlow Lite, and it takes a model, it compresses it into a size of a few megabytes, and it basically is something you can run on any app. I guess it can make a good use case for progressive web apps as well, because those are the things that you want to keep light. So maybe this is a way to extend it to a web as well. I don't know if that's the intended use case. Worth checking for sure. So you can either have a model with TensorFlow Lite, either a model on your phone that you retrain, so what we said that was the online thing, or you can have it on any web server, and then it's basically serving it. And then this is definitely something you can do from any web, any progressive web app, and any app.
Cool.
I think a lot of
Thanks a lot. Yeah.
You talked about on doing stuff on devices. I think a lot of people are also looking to that kind of implementation as a way to preserve user privacy, because if you do the model creation and training on the, or sorry, or you're doing the, you're storing the data at any rate, you're storing the data model locally, as opposed to sending it up to the cloud, and that can be one way in which user privacy
Yeah.
Alrighty, thanks a lot, Natalie. I think we're gonna run up to don't make it longer, but again, we are gonna share our videos, also your slides, and we already share your Twitter here. So in order to say good night, we also gonna invite Majid. It's like my Spanglish, you know why, right? It's like, and also I think it sounds really cool, so I'm gonna try to call you.
Just say that then, if it sounds cool.
I need to put myself on mute every time that I So thanks everybody for being here and actually participate in our actually first YouTube streaming. We're hoping to have more of these conversations soon. We're gonna share these links, and yeah, thanks everybody for coming.
Thank you.
Thank you very much for arranging.
Bye everybody.
Bye.
Bye.